Hi everybody, this is Ryan. I'm here for another video. This time we're going to talk a little bit about section 2.2 and symmetry and intercepts. So when we talk about symmetry, what we're talking about is things that can be symmetric about the x or y axis. And so here's the x-axis. We could be symmetric about the y-axis, and we could be symmetric about the origin. So we're going to talk a little bit about this today. Symmetry with respect to the x-axis, y-axis, and origin. A graph has y-axis symmetry if every point x and y, the point negative x, y, is also on the graph. Algebraic test: replace the x with negative x to see if you get equivalent equations. Meaning, when I start with an equation and I replace an x with negative x, I get the same equation back when I solve it. A graph has x-axis symmetry if every point x and y and the point x negative y is also on the graph. Algebraic test: replace the y with negative y to see if we get the same equation. A graph has origin symmetry if every point x, y, and the point negative y, negative x, negative y are also on a graph. Algebraic test: replace x with negative x and y with negative y to see if we get the same equation. So, intercepts. To algebraically determine intercepts of a graph or an equation, to determine the x-intercept, set y to 0 and solve for x. To determine the y-intercept, set x to 0 and solve for y. So let's try it here. Algebraically determine the intercepts of y equals negative 2x to the third plus 8x. To find the x-intercept, set y to 0. So that's what we did. We let y be 0. And then you solve the equation. So when you do that, you factor. So right here we're going to factor. So you get negative 2x equals 0, which is 0. X plus 2 equals 0, which is negative 2. And x minus 2 equals 0, which is 2. So your x-intercepts are negative 2, 0, 0, 0, and 2, 0. Now you could check this on the graph by going to your graphing calculator, pressing y equals, and entering negative 2x to the third plus 8x in there and pressing graph. You should verify those. Now to find the y-intercept, you said x equals 0. And that was a lot easier. So if you put 0 in for x, you get y equals 0. So your y-intercept is 0, 0. Okay, so here we go. So let's algebraically determine the symmetry of y equals negative 2x to the third plus 8x. X-axis symmetry: replace y with negative y. So I have negative y equals negative 2x to the third plus 8x, and y equals 2x to the third minus 8x. Not the same equation, so there is not x-axis symmetry. So these are going to have to be the same, and they're not. Y-axis symmetry: replace x with negative x. And again, those are not the same equations. So there's not y-axis symmetry. Origin symmetry: replace the x with negative x and y with negative y, and you solve them, and you get the same equation back. So therefore, there is origin symmetry. Now, to determine the intercepts of this, we let x-intercept, let y be 0, and solve that down. And then to find the y-intercept, let set x equals 0, and solve that down. So you can then see what your equations are. So now this one you really can't put it in the calculator to check it because you have 11x and 11y on this side. Now what you could do though is you could solve the equation for y. So you have y equals x to the fourth minus 3x squared minus 28 over 11. So then this right here would go in your y equals and then hit graph. And then to figure out your symmetry pieces, you do the exact same thing we did. Replace y with negative y. And you notice the equations are different. To find the y-axis symmetry, but replace x with negative x, and you solve the equation. Now this time, notice how the equations are the same. So it has y-axis symmetry. Hope this video helped. Again, it's just the main topics, some ideas to share with you. So if you have questions, let me know.